On this show, we're talking about Power over Ethernet and how it's going to impact you during the design and installation work. I brought in an expert to help me.
Don't hang up that phone. We've found what you're looking for. Welcome to the Let's Talk Cabling podcast with Chuck Bowser, RCDD. Well, seeing how we're pulling Category 6A, the most powerful twisted pair in the world, you got to ask yourself this one question. Did I pull 295 or 300 feet? Well, do you feel lucky? Do you, punk? In this podcast, you'll learn the differences between a 66 and 110 punch tool, the proper way to install a support cable, along with testing and certifying the cable. What exactly does RCDD stand for? Registered Communications Distribution Designer. Just the expert you need to ensure your cable plant performs exactly as designed. The elite professional, knowledgeable, and experienced in leading-edge ICT design principles. So join us as we talk about the ever-changing world of telecommunications. From ISP to OSP, from copper to fiber, design to installation. Now, send the new guy to the truck for a bucket of dial tone and the cable stretchers, while you listen to an informative program on telecommunications.
Welcome to the show where we tackle the tough questions that are submitted by installers, project managers, estimators, and even IT personnel. On this show, we connect at the human level so that we can connect the world. If you're watching this on YouTube, would you mind hitting the subscribe button and the bell button to be notified when new content is being published? If you're listening to it on iTunes, Google, or one of the other podcast platforms, would you mind leaving us a 5-star rating? Both those two steps helps us take on that algorithm and help educate, encourage, and enrich people's lives so they can be better in this field. Also, every Thursday night at 6 p.m., we have an after hours live series that's broadcast live on LinkedIn, YouTube, and Facebook. I know I can hear you now, but Chuck, I'm driving home at 6 o'clock on Thursdays. I can't watch it on the car. They're recorded. All you gotta do is go to our website, letstalkcabling.com, and you can watch all of the recorded live streams and even the audio podcast as well. So make sure that you go there and visit. We also do the questions. We do questions on Thursday nights, so submit your questions early to questions@letstalkcabling.com. So on this show, I brought in an expert to help me with Power over Ethernet because my knowledge to PoE is limited to what we just read in the TDMM in our study group. So on today's show, I brought in a Power over Ethernet expert, Hanna Walker RCDD CCNA, because she knows more about PoE than me times 10, because my knowledge is limited to the TDMM. Welcome to the show. How you doing?
I'm doing well. Thanks for having me.
My pleasure. My pleasure. So why don't you give us a little bit of history about you and how you got into the ICT industry?
Great. So I studied in undergraduate school as an architect. So I went to Texas A&M, have my degree in architecture, and I was on my way to get my master's of architecture to continue with my licensing when I met a building owner who was starting to develop and wanted to look at using smart technology in his buildings. And so I was introduced to him. His name is Farouk Aslam, and I started working with him doing 3D models of buildings, and he was looking at the time at PoE lighting. And so I started doing 3D models of a whole building with PoE lights, how they're connected back to the drivers, how they're connected back to the switch, what port they're connected to. And from there, I just started learning more and more about networking. I took some classes and got my CCNA. And then as we developed our business, I then did my own studying and got my RCDD. So now, that was about 4 years ago. So since then, I've been really integrated into the digital building, smart building platforms, using PoE and all types of stuff to create these IoT buildings.
Very cool. I got a question to ask you that I know I didn't already forewarn you about this one, because you got your RCDD and a CCNA. Because you're in Power over Ethernet, doing all of those kinds of stuff. Do you think that the CCNA and the RCDD really complement each other really well for what you're doing?
I think so. And especially if you're going to be the one doing any commissioning, then PoE is going to be really integrated into, obviously, the programming of the switches. So Cisco was a big partner of ours and still is. And so having that knowledge to do the networking, we actually, for our first project that we'll talk about in a little bit, the Sinclair Hotel, myself and my team, we commissioned the entire 350 network switches. And so having that knowledge and how it's working behind the scenes really helps you design the building at the front.
Because that's one of the biggest questions I field all the time is I get questions about certifications all the time. And I contact, depends, you got to do some homework up front. You got to decide where you want to go, right? So that's why I tell people all the time. So tell us a little bit about the company that you work for.
So I work for a company called Sinclair Digital, and it came out of the Sinclair Hotel project. So I mentioned before, boss, who's now the CEO of the Sinclair Digital, and he was a hospitality developer. And so we started developing the project, the Sinclair Hotel, which is where the name Sinclair comes from. And in that project, we identified what components we wanted to make using PoE and using this digital platform. And we did the design, commissioning, install, and all in-house. And then we took everything we learned from that project and made it into a company that does design consulting, design build for other people's projects around the United States. So we're currently working on a project in New Haven, Connecticut, which is another hospitality project. It's going to be the very first net zero hotel building in North America. And we're doing some other projects with multifamily and senior living. And so we kind of fill that niche in understanding, DC microgrids and PoE buildings as a whole and being able to implement those successfully.
And that's a good niche to be filling right now because PoE and building automation and all that stuff is just growing leaps and bounds. And it makes me almost sad that I'm at the end of my career because I'm excited about all this new technology coming down the pike, right? So tell me, so the company, where's it based out of?
We're based in Fort Worth, Texas.
Fort Worth. I used to live in Dallas, not too far away from there. And you guys service the whole United States?
Yeah, well, we started, small here in Fort Worth, but the people that find interest in what we do are really interested in sustainability and having those enhanced guest experiences and using software and using IoT platforms to the full potential. So those customers, might not always live in Texas, which a lot of times they don't. So we do service all over the states.
Oh, I'd love to move back to Texas. I so loved living in Dallas. Actually, I didn't live in Dallas. I lived in a little community outside of Dallas, but Dallas is a great town to live in. Now, before we get started in the content, I guess we got to set a baseline because there might be people listening who may not know what Power over Ethernet is. So can you tell us exactly what is Power over Ethernet?
Absolutely. So Power over Ethernet, or you're going to hear PoE a lot, is basically where you have some sort of network switch, like a Cisco switch, another type of switch, transition, whatever, and it's sending both power and communication over a single cable. So that's the Ethernet cable that you're sending that. And so when they started working with PoE, it started in 15 watts, which is not a lot of watts. It's enough to do phones, some smaller access points, maybe some cameras. But since it was created, it's actually gotten steadily more and more power, and it changes, technically the term, to, UPoE, UPoE plus. So it went to 30 watts and then 60 watts, and now it's actually at 90 watts. So if you think about the evolution of that, now instead of just being able to do voice over IP phones and power our security cameras, we can now do almost everything in the building, lighting, window treatments, air conditioning units, all of that can be done under 90 watts. It's really a large amount of power. And the benefit you get from using PoE is that it is a low voltage, safe to touch cable. So now instead of having to run line voltage AC power, you need electrical labor to do that. You need electrical inspections. I can run all those devices I talked about in the building and more on a low voltage cable that's safe to touch, can't start any fires, and you're getting the data and communication on one cable instead of having two infrastructures.
Yeah, that's a great thing there because electricians aren't cheap. And so if you can get one contractor to do more stuff for you, that's one point of contact, that's less headaches for the customer. And I could have swore that I was in a webinar, or maybe I was in one of my company's trainings. I could have swore they said something about 100-watt PoE stuff as well. Is that a thing, or am I missing something there?
Yeah, 100 watts is the limit. 100 watts is like the limit of low voltage. So it really, they like to say 90 watts because it's 100 watts, leaving the switch, or depending on what switch, it's, so many watts leaving that. But then when you calculate in the cable length and the type of cable and everything like that, it starts to drop down. So 100 watts is now the limit before it goes up to line voltage. So a lot of people, keep it at 90 watts, but the switches typically will push a little bit more, but that's what they will label it as.
So do you happen to know how many amps that is on? Because I think you break it up across all four pair, correct?
Correct. Well, the power is usually passed on to two of the pairs, and the data communication is passed on the other two. And so I don't know the amperage off the top of my head, but I know that it's done in 48 volt DC.
Gotcha. So 100 watts of power. What kind of devices? What big devices can I run with 100 watts? Somebody told me once you can do a 16-inch screen TV, and I just been regurgitating it as gospel.
Oh yeah, absolutely. So our 55 hospitality TVs are around 55 inches. So it's around your 60 watt. And those run about 60 watts.
Oh, wow.
So, and if you're in the mechanical world at all, and you're thinking about HVAC units, there's a HVAC unit called the VRF, which is a variable refrigerant flow. They can do up to 4 tons of cooling on one 90 watt port. 4 tons of cooling. I mean, that's a ton of cooling. So, that's all very doable. Lighting fixtures are very low, so you can usually do, 20 of them on one of those ports, depending on the wattage. So really all kinds of types of things you can do on that 90 watt port.
When I got your name through a previous guest on the show, and I think he mentioned the project that you're going to be talking about here in a few minutes, and he even told me that even the hair dryers were run over Power Ethernet.
So the hair dryers are not on PoE, but the concept is that now with the way the battery technology is being used, is that you can use some of these things that typically take a lot more energy, like hair dryers. We can talk about DC appliances later, like things like microwaves. For hospitality, we'll say hair dryers, we'll say irons. They're building these devices now to have battery storage inside the devices. So there's a couple of hair dryer manufacturers, irons, they have them. So there's battery inside, which gives you that large amount of wattage, because a hair dryer can pull 1400 watts, a lot of power. So you can't power that directly with PoE, but you can charge the battery with PoE. And so you can use these two technologies that are both working in a DC storage and DC power, and power them and use a low voltage backbone to then charge those devices.
So that's just going to naturally lead in. Tell us about one of your Power over Ethernet projects.
So the one that, is our namesake and the one that we talk about the most, the Sinclair Hotel. What we started to do there was, when we started working on it, we were really tackling at first the lighting system. Because if you work in buildings where you need lighting controls, they're very complex. They require the use of control cabling and also electrical contractors. So you've got lots of hands in the pot, and they're very unreliable. They're very hard to maintain because they do have that high voltage component, and they usually are based around proprietary systems. So if you have to maintain it or change some configurations, it becomes very difficult, and you're really reliant on the company that you purchased it from. And so we wanted to find a way to eliminate those, really rigid lighting control systems and do it simpler, because having those control wirings and then having the AC power and, all those things working together becomes very complex. And so we started looking at, well, can we power and control these things using PoE? And so we realized that Cisco had been working on a digital ceiling platform where they were using PoE lighting to do light fixtures. And so that's how we started. And then we realized with 60 watts, that was what we were using at the time. They didn't have the 90 watt standard. We could really do a lot of things in the hotel room. So we realized all of our motorized window treatments, which were shades and blinds, all of those motors were low voltage DC. So then we reached out to that company and we asked them to convert their product to PoE, and they were able to do that. And so we started looking around and trying to figure out what else could be on PoE. So we ended up doing light fixtures, all the mini bars. We have smart mirrors that have a TV, and then I have music and some things like that. So all of that is powered with PoE. And then all of our motorized window treatments, I think I mentioned that as well. So those 4 things. And then we have all the typical things that are PoE, access points, security cameras, some door locks. We have an Allure door lock, which is a PoE door lock. And we're providing low voltage power to all those devices from distributed network switches. So one of the things that you'll hear a lot of times from architects or people that want to do PoE is that, oh my gosh, I'm going to have a huge server room with racks of switches, and they're going to be lots of heat. And I'm going to have to add so much HVAC and cooling and stuff like that. And I'm going to have to worry about cable bundles, and I'm going to have to worry about all the heating and that, the requirements behind that. And so what we did instead was we used a switch called the CDB8U, which is Cisco's 8-port plenum rated fanless switch. And we distributed that throughout the guest rooms so that all of our cable lengths were only about 30 feet max. And so we eliminated all those bundles that typically run through the corridor, and we actually eliminated all of our IDF closets by going this direction. And so if you think about, well, what about all the regular network equipment? Well, we used a GPON system, which is a passive fiber system. So we didn't really have anything in the IDF closets at all, and we distributed the network around the building, which saved you, tons of labor, tons of cost, tons of materials. And if you're thinking about now, well, how did you power those switches? Did you just have an AC outlet in every room? So what we wanted to do was not to use, our goal was to eliminate as much electrical labor as possible, right? So having an extra outlet that we add to every room kind of defeats the purpose of that. So we were looking at another technology for that application. So we talked about what is the power capacity of PoE, 90 watts, 100 watts. If I need to power an entire 8-port switch that gives 60 watts out each port, I need more power than 90 watts. And so we use a technology called digital electricity, and it's a company called VoltServer. And what the market they're in today is they power DAS antenna systems. They've figured out how to pulse packets of energy. It's 700 pulses a second across a class 2 wire. So just an 18 gauge cable, standard speaker cable. They can pass 1,000 watts on one single pair. And so we use this technology to pass power throughout our entire building. And so from the basement where we have our transmitter racks, we're sending this digital electricity throughout the entire building. So all those devices I mentioned that are on PoE, we were able to remove those circuits from the guest room. So we eliminated half of our circuit panels in the entire building. So we reclaimed about 1,000 square feet of usable space that now can be revenue generating space. We eliminated all the conduit associated with that. And then all the electrical labor for 17 floors of lights, window treatments, all the circuits that would be required for all those things eliminated. And so for this project, by using PoE, this combination of power over Ethernet and digital electricity, we actually saved about 16% in the CapEx, and then month to month, we're saving about 40% energy. We own the building, so we have access to all that data, which I'm happy to share that information as well. So that's one of our big flagship projects. And that's really what we started to model our business after, is finding those savings, energy efficiencies for people and using low voltage technologies to do it.
Yeah, I was going to ask you about, and percentage-wise, how much you thought you saved, and you answered that in your response. And I bet you the customer loves the fact that you're freeing up space for revenue, because that's always a big challenge. Customers they never want to give up floor space. We fight that with telecom rooms all the time. They don't want to give up that space because they can use it for revenue generating stuff. So you said you eliminated all the telecom rooms, or just the telecom rooms associated with the PoE stuff?
So because we're using GPON, well, we have one MDF. So we do have one telecom room that is where our OLT sits. It sends and then we just have passive splitters that are on the floor that are in the electrical rooms that are still there, which, don't have any heat. They don't really have a lot of spatial requirements. They're very small and compact. So we did eliminate the IDFs because everything else is just.
That's just so cool. So were you on the design team for that project?
I was on the design team for the owner. Yeah.
Okay. So what special consideration, because estimators listen to our show as well, what special design considerations did you have to factor in or work your way through, doing a power over Ethernet versus a standard structured cable plant?
Right. So the biggest thing there's two things that I'll mention is one, I talked about distributed network. So now where do you put all those switches? So that was one of the biggest challenges that we had is where do we put these to where they're easily maintained, they're not visible, they're in a good, secure location. And so what we ended up doing was we took our millwork package. At first we're like, we're going to put it in the bathroom ceiling. But we have a historic building and we have a very low floor to ceiling height. And once we realized how congested those ceilings were, we realized that that's not going to be an option, And so we quickly got rid of that idea. And then we're thinking, well, maybe we'll put them in the corridors. But again, historic building, we have these historic corridors that are domes with lights and they touch the deck all the way at the top. So, okay, that's out. So we had to go back into the room. And so we took our wardrobe that we have, it's a large FF&E piece, and we just took out a little cabinet and we put a hidden magnetic lock on the back side so that you can just have a magnet and you can open the cabinet. I'm giving away all these secrets, so if somebody comes stays at Sinclair, they're gonna break in. But anyway, finding that space that works for your project is going to be one of the more difficult things about distributed network, but it can save you so much cost and efficiency of cable lengths and things like that. That's our preferred method. So that was probably the biggest design aspect that we came across when we were looking at how do we design this in the building. And then secondly, on the design side, I would also say working with the electrical engineer was huge for us because we had to work very closely with them, educating them as far as like, take all these circuits out here. We need power, this location, this location, this location, which is what you do typically. But obviously, this was a little bit more scope and a more reduction of scope from their side. So understanding one, where your drawings fit into the typical design package, and two, understanding how you relate to the electrical package when you're pushing so many other devices that are usually on the electrical side. Now you're doing it with low voltage. So really working in tandem with the electrical engineer to get the right scope on the right set of drawings.
Yeah, you probably forced that electrical engineer to think outside the box that they were comfortable staying within, right? I'll echo, it was probably a really good decision to not put it in the ceiling of the bathrooms. A lot of non-road warriors don't know this, but road warriors, and I'm one of them, sometimes will do what's called the travel iron, right? So instead of having to iron your clothes, you put them in the bathroom, you turn on the hot shower, on the shower, and you just let it steam up the room to get all the wrinkles out of your clothes. That way you don't have to iron your clothes in the morning. And if you have, some equipment in the ceiling in the bathroom, I could foresee that being a problem.
Well, and you're in the bathroom, you don't want to have this, but we've had lots of leaks and the bathroom's where it happens. And so with them safely in the wardrobe, we have not had any leaks affect our switching. So yeah, it probably was a good idea to keep them out of the bathrooms.
Yes. The next question I have is actually kind of still related to the design side. So Power Ethernet is really known for generating heat on cable, and Article 725 144, Table 725 144 talks about bundle sizes and heat dissipation and all that other fun stuff. What did you do in that project to deal with the heat dissipation on the cables?
Yeah, so that's going back to what we were talking about with the distributed switches. Really took care of that problem, because when you are doing distributed and you're powering them with digital electricity, all we needed for each room to go into the room to power all those devices, we needed one 18.2 cable for the DE to power the switch, and we needed one fiber cable. And so between those two, you're not going to have large bundles going throughout the building. And it doesn't, 18.2 passing pulse power, because it's power limiting, doesn't produce a lot of heat on that cable.
Right.
From the room, now we do have the PoE going out to the devices, but they're very short runs and they're going in all different directions. So you don't have these big bundles. And that's really where you see some of the savings and the advantages of using this distributed architecture.
Gotcha. How did they support the cables in the ceiling in the rooms? To just use Because obviously you probably didn't put in J hooks because usually in hotels ceilings there's usually not enough space for J hooks.
Right. So we have sheetrock ceilings everywhere. So we actually ran Smurf tubes behind the walls and ceilings that ended in the endpoints we needed, like the light fixtures, the TV. That way, over time, technology evolves so quickly. So say we want to upgrade our switches to 90-watt switches in the future. Maybe there's a cable type that we want to change. One thing we talked about briefly was the TVs. So what happens when the TV, I can have a product that's a TV that I can do power, and then you need to pass that, gigabit plus data to it to get that streaming TV live content. Well, I'm gonna need to change that cable because I just ran the Cat 5e when I probably need more like Cat 6a or something else, in the future. So we have those Smurf tubes in place. So we really future-proofed our design. So we can always pull cables back and push it back in without having to cut up the ceiling, like Swiss cheese. And it also gave a protection because I'm sure everyone is aware who's in installation that nobody cares about the low voltage cables. And so they'll just push them out of the way, or if they're doing the sheetrock, they might not be very careful and they'll just puncture those cables straight through. So having that Smurf tube is a really good way to protect it during the construction phase as well.
I don't know what you're talking about. Everybody respects low voltage cabling. I've never had a problem. I've never had sprinkler guys cut my cable. I've never had sheetrock dry guys squish my cable between studs or run screws. That's never happened. Those are just myths in our industry. They never happen. Trust me. Trust me. So let me ask you this.
Must have been our project then. Yeah.
There you go. So as an installer, right, what special things do installers need to know doing power over Ethernet installs?
So depending on the device, one of the benefits of using Ethernet cable, and especially when you're looking at BIM modeling tools, is that you can do pre-terminated cables. And so that's one super big advantage that you can capitalize on if you have a certain typology that will help you, that it's easy to calculate those lengths, because then, you pull the cable and it's plug and play. And that's what we did. We also did that for the light fixtures. So we installed the light fixtures we had made for us had little DC barrel connectors. And so when we pulled the cable, all we did was we just connected the barrel connector, stick the light in, and you're done. And so those are some of the things I would have installers think about is how can we utilize pre-terminated devices to make our speed, double or triple what we could normally do. Because it takes a while, if I'm talking about 20 PoE like Ethernet cables in a guest room, it's going to take a while to terminate all those. I know, people get really fast at it, but how many do you have to go back and re-terminate? But if they're factory certified, you don't have to worry about any of that. You can really speed up your installation. That's probably the biggest thing that I could think of right now. And I would also say that for the installer side, we see lots of benefit of removing the light fixture installation from the electrical scope. So just thinking about maybe installing or having capacity or a skill set to install things that aren't typically in your scope, like light fixtures, like, other devices, like maybe window treatment motors. I know we're getting a little crazy here, but, you can pick up these things and win them to your side if you can offer them at a competitive cost, because that's the reason why people are going away from electrical contractors, is because it's so expensive to do those things. And so we're really asking in our future projects and our other projects we're working on that the low voltage contractor is the one that installs light fixtures, and they're the ones, doing all these other things. So that's a big change, I would say, to the installer side of it.
Have you done any of these projects in areas that are very union heavy, like New York or Philly or New Jersey?
So there's been a lot of, I think actually the most amount of PoE projects have happened in New York, which is obviously very union heavy. So it's a combination of working with the low voltage unions, because there are low voltage unions, and the electrical unions. And depending on how strong those two parties are in the city that you're working in, you might have to, as the owner or the developer, have certain parts of the scope in one or the other's court. Like sometimes you have to still give away light fixture install to electrical contractors to keep the relationships and everything savvy on the project. So it's just a matter of which union you work with, and but we have started to see pushback from the electrical unions on wanting to drop the 100-watt limit to like 30 watts, which is, hopefully that never passes, because it doesn't make any sense logically. It's just kind of like a fear mindset.
Yeah, they're trying to protect their work for their workers is what they're doing, and I kind of halfway understand that, but that's the way the industry's going. That's the way installations are going, and that's what I was saying. When I first got in this industry, all we did was pull cable to telephones and fax machines and computers and printers, and now you named them. Window controls and elevators and digital signage and all that stuff can be done, and just so much more things. And as you said, the more things you can do, the more money a company can make. Where do you see Power over Ethernet, the industry itself, heading in the future?
So we really see buildings going to complete DC microgrids. What I mean when I say that is the infrastructure of buildings has really not changed in 100 years. If you have a photo, we actually have a slide where we have a side-by-side photo of a circuit breaker panel from 100 years ago and one that was installed yesterday. They are the exact same. But if you think about the endpoints, how quickly have TVs and phones and HVAC systems have changed dramatically, but we've never went back and updated the building infrastructure. So I think now that we're proving that all these devices are low voltage inside, we're really going to see a complete shift to the way that we think about building buildings. We kind of see it as the Tesla moment for buildings, where if you think about the car industry recently has gone through the exact same thing. They've been building cars the same way, using fossil fuels and using, a million parts in a car. And all really, Tesla has done is looked at a car and said, I can build this more simpler, easier, more sustainably, and cheaper at the end of the day, once the production and everything. So it's the same thing for buildings. We can do this simpler, easier, more efficiently, and more sustainably by using these types of DC technologies like PoE and digital electricity and other things like that. So I really think that the building industry is at the same place the car industry was, maybe 10, 15 years ago. And it's all shifting towards that.
It's absolutely amazing. And you're funny, you mentioned Tesla. That's such a forward-thinking company. All you do is just look at his rockets, right? And you compare him to Bezos' rockets and just look at the two. You can just tell that they totally take a different approach to how they handle things. And you're absolutely right. Just they're a forward-thinking company. And we need to be that way as well. That's going to drag us kicking and screaming, because unfortunately, a lot of installers are older people, kind of like me, who don't want to change to the new technology. And it's going to take an influx of new people coming in our industry to really force this stuff to go. And I really think it's going to do a lot of benefit for our industry. Let me ask you this: do you have any forward-facing documents about that project that maybe I could post on a webpage if somebody wants to read more about your project that you did?
Yeah, absolutely. We've got a bunch of documentation. We've got a lot of videos too that our partners have made. Intel ended up being a sponsor for our grand opening party. So, Intel, they're very interested in data. And our approach to making a building producing, tons of data that you can use and analyze that's what they're all about. So they did a really great video. So I can definitely share these articles and things that we have for.
Yeah, definitely do. And I'll put the links to them on the page. So that way, if somebody's listening to the show, they can go to the webpage and then click on that link and get more information on it. So I appreciate your time today. I know that we went through kind of a thing there for trying to get you scheduled and stuff, but we got it done. We got you on board, and I'd like to ask if I have any future Power over Ethernet questions in the future from audience members. Maybe if I can reach out to you for potential answers.
Absolutely. Nice. We live and breathe PoE, so
good.
I'll accept any question.
Good. Well, I appreciate your time.
Yeah, thank you for having me. And we beat the lightning storm too. So.
We did beat it. So until next time, everybody, be safe.
That's it for this episode of today's podcast. We hope you were able to learn something. Make sure to subscribe so you don't miss out on future content. Also, leave a rating so we can help even more people learn about telecommunications. Until next time, be safe.